Hello, this is Mrs. Lemke, and I am here to discuss with you, and really, I mean talk to you about the alternating series test. Nothing makes us so happy as alternating, like we do when we walk, left, right, or like we do when we have a series that alternates in sign. That's what we mean by alternating series. So we might have something like -1 to a power, that causes the terms to go back and forth between negative and positive. That's an alternating series. Now, you might not have realized it, but we have restricted our attention so far to situations where we had series that only had positive terms. That ends today because we're learning about the alternating series test. So a question, well, actually more of a comment that we could make is that we know that the harmonic series diverges. We discussed this as a P series. We discussed this in terms of the integral test. And so we know that this series, if I start from 1, go to infinity, I have these terms. And even though these terms are getting smaller, they are not getting small enough, fast enough in order for that series to converge. So you might wonder, well, how about the alternating harmonic series? Because the alternating harmonic series would cause every other term here to be negative. Okay, so pick whichever half of the series you want. And so perhaps that compensates, right? Does that make the terms, like in total, get smaller faster because I'd kind of like be subtracting some, you know what I mean? Like 1 minus a half plus a third minus a fourth plus a fifth. Maybe that allows for some convergence. So in order to answer that question, here we go. So the process for any alternating series. I will point out to you that we are explaining this slightly differently than your textbook does. I immodestly think that we are explaining it better than your textbook does. So just be aware of that if you're looking at examples in your book, for example. All right, so the process for any alternating series. First of all, anytime you identify a series as an alternating series, something that has like negatives involved, these are the steps. First step, see if the positive twin converges. Okay, FYI, positive twin is 100% something that we've made up, okay? So we can't really talk about this in terms of, like writing positive twin on your AP test. But what we mean by the positive twin is if you just look back here, and you're like, okay, which part of this is causing the signs to alternate? Oh, this part. Ignore that. This part. Ignore that, okay? The rest of it is the positive twin. Now, you also could think of this as just having absolute value, right? Taking absolute value of your series, right? Like of the terms. And oh, actually, yeah, and then, yeah. So you could think of it that way, but I think positive twin is just way more fun to talk about, okay? So you have a positive twin. There's like an evil twin and a good twin, maybe. I don't know. So there's a positive twin. And if that positive twin converges, guess what? The alternating series also will be convergent, and it's such, and we kind of distinguish here a separate kind of convergence. There's going to be 2 different kinds of convergence if you have alternating series. This is what is called absolutely convergent because it's the absolute value of the alternating series that converges. Okay, so if the positive twin converges, that absolutely comes from the idea that we actually are thinking about the absolute value, right? Positive twin. Now, if the positive twin diverges, as is the case when we're thinking about our good old friend, the harmonic series, right? We know that if we are just looking at 1 over n, no negatives involved, right? This guy, the positive twin here, is divergent. But we're wondering if putting negative signs in could make it convergent. We're wondering about this, okay? But we know the positive twin is divergent. Now, in that situation, we are going to check a thing called the alternating series test. Now, you only need to deal with the alternating series test if you already know that the positive twin diverges. Now, if your series passes the alternating series test, which I'll explain in a second, if your series passes the alternating series test, then the alternating series is what is called conditionally convergent. It converges on the condition of alternating, because we already said that the positive twin diverged. So it can't be absolute convergence. Absolute convergence is when the positive twin is convergent. Okay. So notice that you perform the alternating series test with the positive twin, but it's telling you about the alternating series. So that's a little confusing, like test over here, test this thing, and it's telling you about this other thing. I think you can handle that. All right, so the alternating series test is the ultimate hand-wavy feeling test. Even after all these years, I just feel like this is not rigorous enough in math. I mean, it is, but it is going to feel like you're just writing stuff without really doing math, okay? It's a frustrating test. Okay, so there's really just 3 conditions. It's a checklist, okay? So are the terms without the sign alternator positive? Okay, so you just want to make sure that there aren't any other hidden negatives. Is the limit of the positive part without the sign alternator, the rest of it, is the limit of the rest of it going to 0? Actually, if that's not the case, like I don't even know what we're doing here, right? Because we need to have terms that are getting small enough, fast enough. We need them to be getting small enough. That's kind of baseline, okay? And then our terms have to be decreasing, okay? So this statement means decreasing. And I hope you are aware, as a calculus student, you have a very specific way of being able to see if something's decreasing, which is a derivative, right? If your derivative is negative, you have something that is decreasing. So that's the most rigorous step, okay? The other steps are going to feel a little like, I don't know. So remember that we are going to be using the term conditionally convergent, because that means that this alternating series converges on the condition of being alternating. Without that condition, then we'd have something that was divergent. We wouldn't be looking at the alternating series test unless the positive twin is divergent in the first place. Okay, are you feeling like your head is swimming? It'll be more clear if we look at examples as per usual, right? Examples always help us understand math. All right, so here is our first guy, and I can see I have some terms written out. That's very nice, and I also have a general form. Okay, so that's my series, and I want to first think about my positive twin. So the positive twin is the absolute value of this. All the terms would be positive. So here is my positive twin. I'm writing out the terms just to help you conceptualize what we're talking about. Okay, and when I look at that, I notice, aha, this is geometric with a ratio of 1/2. Okay, and so that's very good to know. And I know then that this positive twin converges. Therefore, I am done. Okay, so I would say this series okay, and I have to think here, is this starting with n equals 0 or n equals 1? I'm thinking a long time. 1. Okay, that's right, right? Maybe not. 0? No, 1. I forgot that it started negative. Never mind. Okay, so this series converges, is absolutely convergent. I'll say it that way. Okay, so there I am talking about the series with the sign alternators, right? I left that -1 in. So that series is absolutely convergent because the series without the sign alternator, the absolute value, is convergent by geometric. R is equal to 1/2. Okay, so say something along those lines, right? This alternating series is absolutely convergent because the positive twin converges by geometric series. That's in better handwriting. Meh. All right, let's look at our next guy. It's an alternating series, so I want to think about the positive twin. The positive twin is just adding up consecutive integers, friends. Well, what do you know about that? The positive twin diverges by nth term test. Okay, so I know I don't have absolute convergence. Now I want to check my checklist for alternating series test. One of the things on the checklist for alternating series test is, does the limit equal 0? Well, I just said that that's not the case. So no, limit is not 0. Okay, so this points out a special case. If you have divergence of the positive twin according to the nth term test, then this part of the alternating series test is going to fail. Okay, so right here we can say that the alternating series also diverges because we don't pass the alternating series test. Okay, so this guy with the alternator diverges, fails alternating series test. Something along those lines. Okay, the rest of the notes are actually just problems, okay? And I would like you to try the problems and then come back, okay? Something that is interesting about number 5 is that it's not actually an alternating series. It's actually got a different pattern of signs. So we can't use the alternating series test at all because it's not alternating. However, I would like you to check that to see if it's absolutely convergent. Then all that means is take the sign alternator off and look at the rest. Okay, the positive twin. So for problems 3 through 8, I'd like you to now pause the video, do your best to try all of them, and then come back and I will show you solutions as well as explain, okay? If you need to write down where this is, like if class is about to end, feel free to write down where this is in the video so you can pick it up later. Okay, thank you for trying those problems. Here's question 3. So first of all, remove the sign generator so you can be thinking about the positive twin. The positive twin is just going to be this lovely p-series, and we know that that is a convergent p-series. Since the positive twin converges, that means that the original series, the alternating one, is absolutely convergent. The positive twin converges, that's what's called absolute convergence. In question 4, this is a disguised sign alternator, but if we are alternating between these different values of sign, like I'm putting in 1, I've got sine of pi over 2. I put in 2, I've got sine at pi, but sine at pi is 0, so that's going to go away. And so the only terms that are going to remain are the ones that alternate between 1 and -1, 1 and -1. Okay, so there's a disguised sign alternator there. In this one, for the positive twin, I am then going to be ignoring this top part and just thinking about the bottom part, which is this, and I am using the good old limit comparison test here. I compared it to a p-series, and I compared it, yeah, I mean, it is a p-series. I just wrote it in a really kind of weird way. Okay, so instead of saying 1 over n, I said 1 over square root of n squared, which is like 1 over n. So I did a little algebra there, and you can see that the limit is 1, and 1 is a positive real number. So in the limit comparison test, if I get a positive real number result, then I know that those two series behave the same way. And this one behaves The way the harmonic series does, it is the harmonic series. So that means that so too the positive twin will diverge. So I'm up to the point where positive twin is diverging. So that means I need to look at the alternating series test. So I'm going to check my 3 criteria. First of all, removing the sign alternator, will the other terms be positive? You bet. Secondly, will these terms be approaching 0 as n approaches infinity? You bet, because that denominator is going to be getting bigger, 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 so my quotient's getting smaller, smaller, smaller. And then decreasing. You can convince yourself of this either by logic or by derivative. I just used logic and said, okay, my first term is going to be 1 over square root of 2. And then when I plug in a 2, I'll have 1 over square root of 5. 1 over square root of whatever, right? If I'm looking at it without the sign alternator. And so that bottom is getting bigger, 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 and each of those terms is getting smaller. It's not oscillating around, right? Again, remember the alternating series test, the questions I am answering are about the positive twin, even though it's telling me about the alternating series, okay? So yes, these terms are getting smaller as we go, and so we have conditional convergence. This series is convergent on the condition that we do in fact have alternating pluses and minuses. Without that, right, if I just had this series, that series is divergent. Okay, question 5 is the one I mentioned before we went off to work. I mentioned that the signs are not strictly alternating, okay, but I said we should test this for absolute convergence. Meaning we can ignore this sign aspect, right? Think about having an absolute value. Right, so if I have this series, I don't know if I like crossing that out. Okay, so if I have this series and I have absolute value bars around the whole thing, this part is just going to yield a 1, right? The absolute value of 1 is 1, the absolute value of -1 is 1. So this is then talking about that guy, also known as 1/3 raised to the n, which I certainly hope, since this goes back to the beginning, you recognize as being geometric, okay? So that positive twin is a convergent geometric with r equal to 1/3. Which means that this series, although it's not alternating, it's not going positive, negative, it's not doing that, it can be described as being absolutely convergent because the absolute value, the series that results from the absolute value is convergent. I'll say it that way. The series that results from the absolute value is convergent. Therefore, the original series is what is called absolutely convergent. Okay? Here's the stolen answer key. All right, number 6. Okay, in this one, it works really nicely to think in the consideration of the positive twin, to remember that natural log of something is going to be less than that number, which means 1 over natural log of n is going to be bigger than 1 over n. Then this helps us in our direct comparison test. I know that the harmonic series is divergent, so therefore my positive twin version, that series diverges by direct comparison test. Okay, and you might say, oh, but wait a second, this is n plus 1 and this is n. Tomato, tomato, you're just off 1 term. It's not going to change the overall result. Okay, to just add 1 more term. Add 1 term to something that's finite, you get something finite. Add 1 to something that's infinite, you get something that's infinite. Matters not. Okay, so in any case, we have divergent positive twin. So we want to check that using our alternating series test. And when we do check the alternating series test, we have terms that are positive, terms that are decreasing, and a limit of 0. So we should have conditionally convergent for number 6. And number 7, I'm going to look at my positive twin. I'm going to think of this positive twin as this. So how about limits? Limit of this, okay. If I just think about it, it's like an infinity over infinity case, but think about doing like L'Hopital's rule, I'd have 1 over 1 really fast. You know what 1 is? It's not 0, okay? So my positive twin diverges by nth term test. Okay, and this whole slide is about the positive twin, right? This guy. So the positive twin diverges. So that means I need to check my alternating series test. Oh, wait, this is that special case I mentioned. If you're finding divergent by nth term test, you automatically know the alternating series test is going to be a bust, okay? Because the limit isn't 0. So alternating series test can't get you through. So both the positive twin and the alternating series in this case are divergent. Last one, positive twin. Positive twin is this guy, which is a P series. P is equal to 1/2, which means we are in the divergent case. Okay, so my positive twin is divergent. So that means I need to turn to alternating series test, do my checklist on this guy to tell me about that guy. All right, so I go through and I would say, I actually didn't write very much on this slide. Let me do better, okay? So are these terms positive? Yup. Is it true that as I put in subsequent values, the second, like this would be smaller than this each time I go on down the list? Yes, okay, because n plus 1 is bigger than n, right? And so dividing by a bigger thing is going to make a smaller thing. And the limit of this as n goes to infinity, is that going to go to 0? Shenanigans, it sure is. Okay, so we would have conditional convergence of this guy by alternating series test. Okay, all right, so that's that. Hopefully it makes sense to you that you always are looking at the positive twin. The positive twin situation tells you what to do. Okay, so either the positive twin is going to be convergent, in which case you have absolute convergence for the alternating series. Or, if that is not the case, if your positive twin is divergent, then you're going to do your alternating series test. In that alternating series test, either the 3 conditions are met or they're not. If the 3 conditions are met, then you have conditional convergence for the alternating series. And if not, then the alternating series itself is divergent. All right, that's it. That's the logic. Okay, thank you so much, and I'll see you in class, and Mr. Covey will see you in his class. Bye.